Today we're going to work on the difference of squares worksheet. So you have 6 problems at the top, and each of them involves multiplying binomials. So we have x minus 2 and x plus 2. And I want you to multiply these out using the box. So x minus 2, x plus 2, and then fill that in. I'm going to pause the video and let you guys do all 6 problems, and then we'll come back and we'll look at the answers. Okay, I'm back. So the same sort of thing should have happened with every one of these. The first one you get x squared minus 4. The next one you get x squared minus 81, x squared minus 49, and then 36a squared minus 49. Okay, you guys good with those? So, what pattern did you notice in A through D? They were all, what was the word we learned last time? Starts with a C? Conjugates. So A through D are all conjugates. What are conjugates again? They're exactly the same, but the sign between them are opposites. So conjugates. Okay. And what do we call a quadratic that is created using conjugates? Difference of perfect squares. So those are the first 3 questions down below. Okay. All right. What did you get in E? Hold on. You got. So E we started with 6x minus 22 multiplied by 3x plus 11. And you're going to get 18x squared minus 242. And then 6x squared plus 15x. And then 2x minus 5. 12x to the third minus 75x. Okay. Did the middle terms cancel? Yeah. Why? Oh. So I said yesterday that the only way to cancel a middle term is to have conjugates. But we just multiplied 2 different problems together that are not conjugates, and the middle term canceled. You jamming out? Can you hear me? I can hear your music. So it turns out we really do have conjugates. They're just kind of hiding. So look at this. What do 6x and negative 22 have in common? Not a 3, a 2. Let's pull a 2 out. If we pull a 2 out, I get 2 times 3x minus 11. And there you see the conjugates. Right? Okay. What do these have in common? A 3 and an x. So let's pull out a 3x. What's left? (2x plus 5). And there you see the conjugates. So it turns out there were conjugates underneath there all along. We just couldn't see them because they were hiding underneath another problem. So if I asked you to factor x squared minus 144, what would the factors be? X plus 12 and x minus 12. So on G through L, all you have to do is factor and you're done. But on M through R, it says find the roots. How do we find the roots? You write equals 0. We're going to subtract 12 and add 12. And I get plus or minus 12. So this is factoring. This is finding the roots. Okay, let's do one that's a little bit harder. What about 9x squared minus 25? What are the factors? 3x plus 5 and 3x minus 5. So if it says find the roots, this is a little bit harder. Okay. And then what? Divide by 3. And we get x equals negative 5/3. Is everybody okay with those? All right. Now, no? Do you need to see another one? Okay. Let's do another one. 7x squared plus 4. How does that factor? Oh, not 7. That doesn't work. I meant 49. X squared plus 4. Oh, you guys are overlooking something. What's wrong with this? It's a plus. It cannot be factored if it's a plus. Okay, now I'll fix that. Change it to a minus. So, what are the factors going to be? Do you get that? Okay. So now we write equals 0. We're going to subtract 2. And then divide by 7. So I get x is negative plus or minus 2 sevenths. Okay. All right. Now, what about this? This one's a little bit harder, and you are going to see some of these on the next page. So Tyson, this is the one you wanted to know about. So does this represent a difference of perfect squares? No. It's not a difference of perfect squares. But do you see anything in common? Oh, well, that's not going to work, actually. There we go. I messed up. So, Money, what do 27x to the third and 3x have in common? 3 and an x. So I need to yank out a 3 and an x. When I do so, what's left? Now do I have a difference of perfect squares? Yes. So that 3x stays on the outside. And on the inside, I get 3x minus 1 and 3x plus 1. Okay, so those are the factors. How many roots does this have? It has 3 roots. How did I know at the beginning it has 3 roots? Because it's a third power, which means there are 3 x's, which means there are 3 places it hits the x-axis. So the first one is just 0. So it's not that's a good question. It's not a parabola. It looks like this. It hits 3 times. So I write equals 0 on all of those. And the first one's easy. Divide by 3 and I get What is 0 divided by 3? 0. So the first answer is 0. What is the second answer going to be? We're going to add 1 and then divide by 3. And then what about this one? We're going to subtract 1 and divide by 3. So the answers are 0 and plus or minus 1/3. So the graph actually looks like this. It hits here. This is -1 and 1. It actually looks like that. Hits it. Oh, I missed. It looks like this. It hits at -1/3, 0, and 1/3. Okay, does that make sense, Tyson? All right. Okay, you can do everything. The answers are on the bottom. So we're going to grade your work. If you don't show work, you're just going to get 0. So go ahead. Just write down all the answers. Okay, get to it.